Imagine a plane designed for the worst possible day in human history. A plane built to survive nuclear war, electromagnetic pulses, cyber attacks, and global catastrophe. A plane so advanced that it could control the entire military of a superpower from the sky. This aircraft is known as the Boeing E-4B Night Watch, often called the Doomsday Plane. Its mission is simple but terrifying. If a nuclear war or massive disaster destroys command centers on the ground, the government and military leadership can take command from the air. This aircraft ensures that even if the world below is falling apart, national command can continue to function. But how sophisticated is this plane really? And if such incredible technology exists, why can't commercial planes be built the same way? To understand the answers, we first need to understand what the Doomsday Plane actually is. The Doomsday Plane is built from one of the most recognizable aircraft in aviation history, the Boeing 747. But despite looking similar on the outside, the inside of this aircraft is completely different. Instead of rows of passenger seats and luggage compartments, the interior contains military command centers, secure communication systems, briefing rooms, offices, and operational control stations. It is essentially a flying military headquarters. If the worst possible scenario were to happen, such as a large-scale nuclear attack, the president and top military officials could board this aircraft and coordinate the country's response from the sky. The aircraft would function as a mobile command center capable of directing military operations across the entire globe. Now let's answer the first big question. How truly sophisticated is this plane? The truth is that the Doomsday Plane is one of the most advanced aircraft ever built. One of its most important features is protection against something called an electromagnetic pulse, also known as an EMP. An electromagnetic pulse is a massive burst of electromagnetic energy that can be produced by a nuclear explosion in the upper atmosphere. This pulse can instantly destroy electronic systems over a huge area. Modern aircraft rely heavily on electronics. If an EMP were to strike a normal aircraft, its systems could fail immediately. But the Doomsday Plane is designed differently. Its electronics are hardened and shielded so they can survive the effects of an electromagnetic pulse. This protection allows the aircraft to continue operating even in the aftermath of a nuclear explosion. Another incredible feature of the aircraft is its communication capability. The plane can communicate with military forces almost anywhere on Earth. This includes satellites, military bases, naval fleets, underground command bunkers, and even submarines deep underwater.
To make this possible, the aircraft carries a large number of powerful communication systems and antennas. One of the most unusual systems is a trailing wire antenna. This antenna can extend several kilometers behind the aircraft while it is flying. It allows the plane to send very low-frequency signals that can reach submarines far beneath the ocean's surface. This means the aircraft can still communicate with nuclear submarines even during a global crisis. Another major capability of the Doomsday Plane is its ability to stay in the air for extremely long periods. The aircraft can perform mid-air refueling. This means that while flying, it can connect with a tanker aircraft and receive additional fuel. As long as refueling aircraft are available, the Doomsday Plane could theoretically remain airborne for days. This is important because during a global catastrophe, airports and military bases might be destroyed or unsafe to land. Remaining in the air ensures the aircraft stays protected and operational. Inside the aircraft, there are multiple areas designed for command and control operations. There are briefing rooms where military leaders can analyze the global situation. There are secure communication stations where operators can maintain contact with military forces around the world. There are planning rooms where strategic decisions can be made in real time. There are also rest areas, sleeping quarters, and facilities to support the crew and passengers during long missions. Every part of the aircraft is designed for survival and continuity of command. Another important feature is redundancy. Redundancy means having backup systems for everything. If one system fails, another system immediately takes over. Critical equipment on the aircraft is duplicated multiple times. This ensures that even if some systems are damaged or malfunction, the aircraft can continue operating. The designers assumed that during a major crisis, systems could fail unexpectedly, so they built the aircraft to survive multiple failures without losing functionality. But building and operating such an aircraft is incredibly expensive. Each Doomsday Plane costs hundreds of millions of dollars. Maintenance, upgrades, specialized equipment, and trained crews add even more cost over time. These aircraft are operated by the United States Air Force, and only a small number exist. At least one aircraft is kept ready at all times in case of emergency.
Now we return to the second major question. If such an advanced aircraft exists, why can't commercial planes be built the same way? To understand this, it helps to compare the Doomsday Plane with the aircraft most people fly on every day. Most passengers travel on aircraft such as the Boeing 737 or the Airbus A320. These airplanes are designed primarily for transporting passengers safely and efficiently. Inside a commercial aircraft, the space is filled with passenger seats, overhead storage compartments, galleys for food preparation, and lavatories. Everything about the aircraft is designed to maximize passenger capacity and comfort. The Doomsday Plane has a completely different interior. Instead of passenger seats, it contains communication equipment, briefing rooms, command stations, and offices. Commercial airplanes communicate mainly with air traffic controllers and airline operation centers. The Doomsday Plane, however, can communicate with military forces all around the world, including submarines deep beneath the ocean. Another major difference is protection. Commercial airplanes are extremely safe, but they are not designed to survive nuclear warfare or electromagnetic pulse attacks. The Doomsday Plane is specifically engineered to survive these extreme threats. Weight and efficiency are also important factors. Commercial aircraft are designed to be as fuel efficient as possible. Airlines must keep operating costs low to remain profitable. The additional shielding, communication systems, and reinforced electronics on the Boeing E-4B Nightwatch add significant weight. Adding such systems to commercial aircraft would reduce fuel efficiency and dramatically increase operating costs. There is also the matter of purpose. Commercial aircraft are designed for everyday transportation. The Doomsday Plane is designed for a rare and extreme situation, maintaining national command during a catastrophic crisis. Because of these differences, building commercial airplanes with the same capabilities would not be practical. In simple terms, commercial aircraft are built for efficiency and passenger travel. The Doomsday Plane is built for survival during the worst possible global disaster. In the end, the Doomsday Plane represents one of the most sophisticated pieces of aviation technology ever created. It is not designed for luxury or commercial travel. It is designed for survival. Its purpose is to ensure that even if the unthinkable happens, leadership and military command can continue to operate. It is a reminder of how seriously nations prepare for worst-case scenarios. And if that worst day ever comes, when command centers on the ground are gone and communication networks collapse, control may not come from a bunker or a building. It may come from an aircraft flying high above the clouds.